Rock mass failure does not always involve discontinuities. There are cases, especially for excavations, like the tunnel you see on this photo, where the stress simply exceeds the strength of the rock matrix, and hence this later can fail. We have seen in a previous topic that creating an opening in a rock mass modifies the stress distribution in the ground. Some stresses would increase and some would decrease. The increase of stress could lead to failure. For an opening, failure typically occurs in the vicinity of the excavation wall. You see here an opening, and close to the opening an horizontal stress and vertical stress. We've seen in a previous topic that this vertical and horizontal stress evolve from the distance to some value on the wall of the excavation here. Typically, if the excavation is left unsupported, the horizontal stress decreases from the far field value to 0, while the vertical stress increases from the far field value to a higher number here. It might be under some conditions that this value of stress in orange here exceeds the strength of the rock in yellow here, in which case all this part of the rock here would have failed. This is why failure occurs close to the excavation and typically rarely in the far field. This type of failure often involves formation and detachment of thin slabs and is called spalling. Research has shown that for a single circular opening, spalling develops in the form of a V-notch, such as this, on two sides typically of the opening. The depth of the V-notch and the inclination of this V-notch depends on the stress magnitude in the field and the orientation of the stresses in the field. The process stabilizes when the geometry has become compatible with the stress fields in the ground. In underground mining, there are typically several openings that can be affected by spalling. On this figure, you see the openings represented by the rectangles there, with pillars in between two openings holding the roof up. What could occur is spalling on the side of the pillar, where you'd have slabs detaching from the side of the pillar and falling off, and you could have spalling of the roof as well. Spalling of the roof creates a hazard for the workers because blocks are falling on the workers, but this is typically not critical for the stability of the whole mine. However, spalling of the pillar is more critical because this could lead to total pillar failure and jeopardize the stability of the mine. This type of failure can be fairly slow, with slabs detaching and falling off the walls, but sometimes this can happen in a dynamic way, and this is called rock burst, where we could have very violent release of energy of the rock, and the rock would burst into the excavation. I invite you to watch the videos on YouTube. There are two videos in additional resources. The first video shows a rock burst event in an underground mine, and you could really hear the rock bursting. The second video shows how critical rock bursting is for the safety of workers. Every year, accidents occur in mining environments because of rock burst. This now concludes the module on mining geomechanics. The elements presented in this module are useful when designing surface and underground minings, which is the topic of the coming two modules. Mining geomechanics is a very complex topic, and only a limited and simplified content was presented in this module.